Hi, let me tell you about another great Manning book, Machine Learning Algorithms in Depth, written by Vadim Smolyakov.
Machine learning algorithms are categorized into supervised learning, unsupervised learning, and deep learning. Supervised learning uses labeled data to learn a function that maps inputs to outputs, with classification and regression as its two main types. Unsupervised learning finds patterns in unlabeled data, such as clustering. Deep learning, a subset of ML, uses layered computational graphs and is applied in various complex tasks. Learning ML algorithms from scratch is beneficial for selecting the right algorithm, explaining results, solving complex issues, adapting to new challenges, and improving model performance. It also helps develop the intuition to troubleshoot advanced ML problems and extend existing algorithms to meet your needs. A solid foundation in applied probability, calculus, and linear algebra is essential for understanding ML algorithms. Key concepts include random variables, distributions, differentiation, integration, and matrix operations. Recommended resources include Introduction to Probability, Calculus, and Introduction to Linear Algebra. Bayesian inference updates prior beliefs with new data using a probabilistic model. It involves determining the posterior distribution using the Bayes rule. Probabilistic graphical models, PGMs, and deep learning models like deep neural networks, DNNs, are explored, including architectures such as CNNs, RNNs, and transformers. Bayesian inference methods include Markov chain Monte Carlo, MCMC, and variational inference, VI. Deep learning's evolution and its role in progressing towards artificial general intelligence, AGI, are also discussed. Effective algorithm implementation requires coding skills and understanding of data structures and problem-solving paradigms. Python is the language of choice, with a focus on object-oriented programming, OOP. Data structures like arrays, lists, maps, and sets are crucial for ML algorithms. Problem-solving paradigms in ML include complete search, greedy, divide and conquer, and dynamic programming, each with specific applications in algorithm design. In summary, mastering ML algorithms from fundamentals is crucial for effective problem-solving, adapting to new situations, and advancing the field.
Get this book at Manning.com